Good afternoon, everyone. My name is Dóra Surina. I'm an architect at Menzor 3D Ltd in Hungary. I would like to present you the survey data processing methods and the way it supports architectural communication, architectural visualization and communication. We at Menzor 3D are using advanced 3D technologies during our projects, as you will see in this presentation. We support many application areas from cultural heritage protection, architecture, or mechanical engineering. Hungary is incredibly rich in cultural heritage. Its preservation, documentation, and high-quality visualization is of common interest. Nowadays, there are several modern computer-supported surveying technologies which can be used to survey different building elements, whole buildings, sites, or streets. But before talking about these technologies, I want to ask something. Who heard about this very famous point cloud? Just, okay. And who worked with it? Because we hear about it, but who is the one who worked with it? Yes, okay. Not just not the majority of this session. So I would like to present a small, short presentation about these technologies. The first one is terrestrial laser scanning. It's ground-based equipment which measures the position and dimensions of the objects with laser light. It became popular because it provides direct, reliable, and dense surface measurements in different situations. The TLS can be used to document even a room or a whole industrial field within centimeter accuracy in 3D. The result of it is the point cloud. It is an enormous quantity of points in space. Each point has an XYZ coordinate, laser reflectance value, and it optionally can contain RGB color information too. Here we can see three ways how we can visualize a point cloud. Each one has its own advantage. For example, intensity colored point cloud, from it we can draw conclusion of the material because of the laser reflectance value. The RGB color point cloud helps us to understand the point cloud, the building, what was surveyed itself. The second one is the structured light scanner. It is mostly used to document medium or small sized building parts, entrances, capital of columns, ornaments in high resolution and accuracy. Its result is a polygonal mesh model which contains the object's original color and texture. This mesh is suitable for 3D printing or can be the basis of a one-to-one CAD model. This is one of the stones what was documented with SLS. Here you can see the picture from the object, the raw mesh model and the textured one with the original textures of the object. Here you can see the mesh contains every cracks and missing parts which come in the object itself. The third one is the area photogrammetry. This is a 3D documentation technology which uses digital cameras to survey the position and the geometry. We usually use the unmanned area vehicle in our cases. One major advantage of the UAV is the small size of the equipment and decreased on-site measuring time, although it can be used indoor. The accuracy and resolution is sufficient for multiple purposes, but these depends on the light and weather conditions. The result of this technology is hundreds of aerial images which can be transformed into a point cloud. In this case, the point cloud, the point has XYZ coordinate, of course, and RGB color information. The laser reflectance value what is missing. Here you can see more than 900 aerial images positions which were taken during the survey of the Solomon Tower in Visegrad, Hungary. You can also see the routes, the 3 different routes in 3 different heights, what we made with this UAV system. Based on the objects, the requirements and experience, the survey method must be chosen after careful selection. Since these technologies have limitations, in order to achieve faster results, high efficiency and accuracy, the combination of these methods are required. We commonly use terrestrial laser scanner as a basic equipment and combine it with SLS or UAV. The survey with the laser scanner requires the same phases. The first one is the pre-processing. During this, we collect every data what is available. We plan the scan positions and the route before the scanning. The second phase is the survey itself. We place physical control points to support the scanning. We do then the scanning, and if it is required, we take panoramic images in the scan positions also. The third one is the post-processing. First, we do the registration of the individual point clouds with control points or cloud-to-cloud method. Then, if panoramic images were taken, we do the coloring. This is how an intensity point cloud can get RGB color information. Then we have the whole point cloud. We remove the unnecessary data information because this is even in this way is a huge and big data. Then decimating to the required size and the point, the different point accuracy. In this case, when we are at the third part, we get the basic for final product like architectural drawings or visualization. In the following, I would like to present you some of our work projects. The first one is the Ferenc Puskás Stadium, the survey of this stadium in 2014. The scan data provided vital information for the partial demolishing and transformation of the building and documented the stadium in its current way. This 3D digitalization is the last memory of the stadium because the reconstruction started in this year. Combination with the terrestrial laser scanner, UAV technology was also used. The whole building, 72,000 square meters, had been surveyed from 1,400 scan positions for 4 months. And the 2 individual datasets were combined with physical control points, which were surveyed by total station also. Here you can see this is the one part of the stadium where we take panoramic images. This is the RGB colored point cloud. After the processed and registered point cloud, we made the stadium's architecture survey plan, 232 drawings altogether. But how we made these? First, we limited the point cloud to the discussed part, in this case the pylon. Then we made a section which was specified earlier. Based on this point cloud section, we made a 2D vector drawings and then we published it. From the point cloud, we also made orthogonal point cloud images. It was used as a layer under the vector drawing and provided measurable additional thematical information next to the vector drawing. 1 year after the survey, the structural engineers of the stadium faced an unusual situation. Based on our 2D drawings, the basement of the tower had thinner walls than in the ground floor. Based on the virtual data set, we could make a cross-section from this point cloud, and we proved that there is a difference without further survey. Another work project is Prone Castle. The whole building was documented with TLS. UAV was used to complement the datasets and to survey the castle park. The two datasets were merged with cloud-to-cloud registration. Here you can see the whole point cloud from the cellar to the attic. The whole building is documented. After the data processing phase, orthogonal point cloud images and 3D architectural drawings were created. The section of the point cloud shows the real undistorted section of the building and gives measurable geometric and thematical information without the vector drawing. A 3D model was also created based on the point cloud. The model and the orthogonal images were made for architectural visualization and to demonstrate the possible utilization of the many abandoned mansions in the country. The Porta Speciosa is an ornamented entrance of the Benedict Abbey of Pannonhalma. This video shows how we made the documentation with SLS. The TLS was used to capture the cloister. Here you can see the TLS data sets from the cloister and the entrance and the color point cloud. This visualization method, what you saw 3 times before it, called point cloud fly-through video. This is the final product, a 3D mesh. It can be used to reconstruction and build hypotheses and verify them. Our last work project is the abandoned waving factory. It was documented with TLS and UAV. This is the video, time-lapse video of the area images. The processed and registered point cloud was cut into separated parts, and we put it to ArchiCAD. Let's have a closer look. The real section of the point cloud. It shows every visible element, like hidden cabinets or downed pipes even. The ArchiCAD is 19 is the first version which can import point cloud, but it's really user-friendly. With Mark tool we can separate the wanted part, and it shows us just it would be a simple 3D model. There are a lot of advantages of the 3D surveying model, what I tried to tell you, but I think one of the most grateful own advantages that the whole design team can use the same survey dataset, which provides the communication and productivity of the team. I hope that this presentation show you how the point cloud and the 3D modern technologies can support these fields, the communication and the visualization. Thank you.